And we should be recording. All right. I don't think my computer can handle this, so I'll just turn off the camera and share my screen instead. All right. Hopefully you're seeing Visual Studio Code.
Yep.
Awesome. All right, so the purpose of this video or meeting is to explain how to implement implementers for existing capabilities. So that's things like KV, MQ, PubSub, or distributed locking, the lockd interface. To develop something for a new capability entirely, you'll first have to create a switch, and so it's best to create a PR for that first, and so we can discuss the design for that and then move forward with the implementation. So this brown bag meeting is not really for that, although same principles of implementation design and implementer will apply still. Anyway, with this said, today we'll be implementing or re-implementing the Mosquito MQTT implementer for the PubSub capability. So to start off, I figured I'll do just a quick overview of the repo structure so we are familiar with our location. So let me minimize everything, and hopefully the size is big enough so everybody can see. If not, I can just make it bigger. Let me know.
Yeah, it's fine.
Cool. So in the root, we have just a source folder, which is this is for SpiderLightning itself. We have an SDK, which is empty and actually doesn't even exist anymore in the latest version of the repo, and a core, which contains mostly just two things: secrets, we don't really care, and the slide file, which is just a specification for the slide file, which is a configuration file that developers use in their own applications for adding capabilities, something like the cargo toml, if you're familiar with Rust. This is the spec for that. And that's SpiderLightning. Next up, we have Slide, which is the CLI for SpiderLightning. So we have mainly two things. Obviously, we have a main where we get the command line stuff, and so like a command that we are running, so say run or secret, and we get specific config, which is the path to our slide file. So we have then the two commands. So let's take a look at run. In run, you see we have sort of a list of implementers that we have. So we have a KV file system, KV AZ blob. This is where they're defined. And at the bottom, we should have, sort of just like a match, which is sort of like a case, right? Where we will go through the slide file that is provided by the user and then just link those capabilities. So link a capability for KV, link a capability for MQ, if those have been defined in the first place. So that's overview of slide. Next up, we have crates. And this is where the implementers themselves are. The implementers are actually some useful things that are sort of across all the implementers, like the runtime or something we call common. And in here, you can see we have the ones that you expect, right? KV, lockd, MQ, PubSub, and other things like HTTP and events, and their respective APIs and useful little macros. And the last thing, or actually one before last, is examples. The ones that we'll care about in this tutorial is just the PubSub consumer one and the PubSub producer. And this is actually like developer applications, right? Something that someone would write. And general gist, right, is they just import the width that we have, and they can then access all the things from the width, and I'll show in a second. So do things like open or send messages and so on. And they also have their slide file, which is what I mentioned, right? Which is sort of similar to the config.toml file. They have a spec version, a secret store name. But again, I'll go over this in just a bit. Just want to overview real quick. And lastly, we have tests, which we won't be touching at all in this tutorial, but I figured I'll just show. They're similar to the examples, the way that we just import the width and then do things with it. But the difference is just that we programmatically call the slide CLI to test it with integration tests. Cool. That's an overview of the repo. Also, if anyone has any questions, feel free to cut me off and ask. All right. With no questions, let's start with the implementation. I mentioned that in the latest version of the repo, we don't have something like the SDK file, right? The reason for that, and the reason why we still have it here, is just that I branched off before this video to a specific commit hash, just create a branch off of it, and I did that because everything that we'll be doing in this tutorial is documented in this file right here, which is in the GitHub repo. And this document is a service implementation 101 doc. This sort of goes over everything that we'll talk about here, and it does branch off of there. So just to make sure we're aligned, that's why I'm doing that. But nothing that you learn here is out of date. Everything will still apply. Cool. So having branched off of there, we checked out to it, and now we can start. So first things first, like I mentioned, we'll be implementing Mosquito implementer. So in the cargo toml, let's just quickly add a couple of Mosquito dependencies. So there'll be a pub/sub Mosquito deps, all adding mosquito.rs futures, which is from WebAssembly we can have awaits or like async calls. So futures, what it does is just lets us block on it, and the async channel dependency is just for the message receiver. Cool. Now, let's go to the pub/sub library. So in here, this is a long file, and I think this is a good moment to just, I guess, take a step back to that wit, which I haven't showed yet. So you see, actually, right here at the beginning, we do a wit bindgen wasn't-time export pub/sub.wit, and this pub/sub.wit looks exactly like this. It will import a couple of types like message. You can imagine how that's useful, an error, and a payload, and everything from resources, which I actually don't think we're using here. I think resources just define something for our watch interface. So if you want to get started with a PR, removing just this line is a good starting point. But yeah, it defines two resources, a pub and a sub. They have open functions and their respective things that pubs and subs do, like send messages to a topic and subscribe to a topic and pull for messages and so on. And how that looks like in the dev side, we sort of got a glimpse of that already, right? If just quickly go back to it, we do an import, put up pub/sub wit, and we can then access those functions that we are defined in the wit, right? And where we also have the slide file, which specifies the specific implementer through a capability name. But now on the host side, what that looks like is this this wit bindgen export and the use of pub/sub all gives us access to this pub/sub trait, which we're implementing for our pub/sub type. This coming off of the file name. So our pub/sub type is just this. It contains a host state, which for now we don't really care about. We're really just looking at the trait. And what the trait gives us is, this might be sort of odd, but this is how the wit bindgen folks did it. It gives us access to two associated types, and these are the resources that we specified. So pub and sub. And these pub and subs, we're tying them to our own types, which are pub inner and sub inner. So you can see here the pub inner description that we added. It was a pub/sub implementer, which would be Confluent, Apache Kafka, Mosquito, and a resource descriptor, which is just a UID that uniquely identifies that resource in an internal structure to Light, which is a resource map. Cool. So with that, you saw that in the develop application, we made calls to something called open, right? And that was coming from the wit. And what that looks like in here is just that we implement that function. So, and we do that through something that we call dynamic dispatching. So we create this inner, and we do a self pub/sub. So this is actually accessing that associated type, and a new. And for the new, we're passing, you see, we're accessing that host state and a pub/sub implementer. And this is coming directly from that slide file. So this would be equivalent to what we saw right here. So pub/sub dot confluent Apache Kafka, right? And the full slide state, which obviously you don't know what that looks like, but we'll go through it. So next up, let's take a look at this new to show you what I mean by the dynamic dispatching. So it just creates well, the pub inner type, which, as we saw, contains a pub implementer and sub implementer. But it does that by calling the pub implementer new, a bit duplicate. But it does this because in here we do a match for specific pub implementers that we have, right? So in this case, we only have the pub sub confluent Apache Kafka. But as you can guess, in our tutorial, we'll be adding a new one, which will be the Mosquito. So you see that it's dynamically dispatching because depending on what it gets in the slide file, it routes to different parts of the code. All right, now let's actually write some code. And a good point to start is actually right here in the pub implementer. What we'll be doing is we'll add, say, a Mosquito. This is just an enum, right? So we have the confluent Apache Kafka one, and we'll call this Mosquito, and it will hold a struct, I mean, that we obviously don't have yet, but we'll call it Mosquito implementer. Same way that a confluent Apache Kafka does. And as you can probably guess, the Mosquito implementer will just be the implementer itself that contains things like a Mosquito client and a receiver and so on. Similar to how we have something for the pub implementer, now we have to add Mosquito for the sub implementer, which is just down here. This is obviously most applicable to pub sub because we have two resources like a pub and a sub. But in the KV, for example, we only have one resource, so you only have to do this once. A Mosquito, and again, the same Mosquito implementer. Just want to point out right here that this is sort of a choice, right? We could create different implementers for the pub and the sub. Right here, I'm just choosing to create one. You see that for the confluent Apache Kafka, that's exactly what we did, right? We have a pub confluent Apache Kafka implementer and a sub one. But here we're just creating one for simplicity and also because it's useful in some ways. All right. So yeah, any questions? Maybe this is a good point to pause. All right, if not, I'll just continue. Hopefully there's no questions because I'm doing a good job and not just going completely over everybody's heads.
No, it's straightforward.
Okay, good. Next up, we'll just add the Mosquito implementer right in the specific new functions. So right here, yeah, go ahead.
What happens if you have a pub implementer but no sub implementer? Like, let's imagine,
yeah, is
there such a service that I would have just publication and no subscription for pub sub, or how would that work?
Yeah, in the host side, you have to implement them both, but I mean, the developer can just use a pub, and that's actually how our examples are set up, right? We have a pub sub consumer demo, or they're just using a sub. They're doing a sub.open. They never access the pub in the first place. And in the producer demo, they're doing the exact opposite. They just access a pub and never access the sub one in the first place.
Thank you.
Okay, thank you for asking.
And just to elaborate, for implementation, if you don't want to implement the sub, you can just implement that type with the unit type.
Yeah, that's true. So what that looks like in code, right? You could just say, instead of that pub.inner, right here, you can just nothing, right? Obviously, your implementation will be lacking, but something you could do. Cool. Now, just going back to where we were, I think we were in the pub. Yeah, pub implementer. We'll just add the new string for the Mosquito, which, I mean, this is the time where you can define whatever you want, right? We could call this Bob, but we'll call this Mosquito because it makes sense. And in here, you can even copy this line. We'll do something very similar. We'll just call self on the Mosquito. So that's accessing that variant in the enum. And here we'll call the Mosquito implementer new and pass in, I guess we'll pass in the slide state as well. Obviously, this is sort of setting the base for what we want to implement in the first, in the end, right? So we know that for the Mosquito implementer, when we do get to it, we'll have to implement this new function. And cool, we can copy this and just move down to the sub implementer and paste it in. And I just reformatted it, and that's why it looks kind of odd, but good. Obviously, Russ is complaining that doesn't exist, and we're missing a comma here. A comma here as well. But with that, we have the two implementers, and now the open function already works, right? So it dynamically dispatches to both of them according to the pub implementer that it gets perfectly. Obviously, the rest is not dynamically dispatched. So say I send message to a topic, it still gets the pub implementer, and it only ever finds the Fluent Apache Kafka one. So we'll have to do this later on. But now what we'll do is we'll actually add the implementer for the Mosquito, because I feel like we're a bit overdue for that. So in here, this is inside, so we were in lib, now we're looking at implementers and the mod file, which we'll just define. The way we organize it just in here, we define the specific implementers that we have, right? So we had the Apache Kafka, and here we'll just say Mosquito. And that translates to a file inside of the implementers folder called mosquito.rs. Cool. Now, this is a lot of code, so I have it written on the side, and I'll just copy and paste it, but we'll go through it all. Here, I mean, you can ignore the imports. We're just going to look at the implementation. We define this pub sub Mosquito implementer, and it needs to implement a debug. You don't have to care about that. And we create specific implementations for the Mosquito implementer. The way I separated it is just that we have a new function which applies both for the pub and the sub. So that's one implement. And obviously you could do this under the same implement, but I just separated it for convenience sake. Then we have a pub, which has the send message to a topic. And we have the Mosquito implementer for the sub, which has subscribe and poll for message. So these are now the functions that would be dynamically dispatched. Now we could implement sort of all of this, but I feel like that doesn't really apply to what we're trying to learn, right? Those are just implementation specific. So again, I'll just paste it in, but I mean, if we want to, we can go over any specific details. Mostly I'll just sort of briefly go over it. The Mosquito implementer, we have the client, we have a specific host. In this case, you'll see that we're set to use a local host and a port, which is 1884. Subscriptions, which is a list of subscriptions that we have, and the subscriber object. Then the new, it creates a client with an auto ID. It sets, we get the host, we get the port. Here we're accessing the slide runtime configs, and we create the object. Same thing with the send message to a topic. We format it in a specific way. We block on connect, and we block on a publish. And this is really just using the capabilities from the Mosquito library. For the subscribe to topic, we add the subscriptions to that vector that we showed in the struct itself, and pull for message, block on connect, and block on a subscribe, and block on the actually receiving of the messages, and then just return them.
Hey, Dan.
Yeah.
I thought before you went into this file, maybe it was mod.rs. In one of your implementations, it was like doing a switch on the implementer it's supposed to be working on.
Yeah.
Can you go back to that code real quick?
Sure. That's actually where we're going next. Do you mean right here?
Yeah, this is what I was wondering about. I'll be quiet until you say what you're gonna say. Then I'll ask my question about this code.
Okay. Yeah, so right here, the step that we're working next is just that now we have the implementer, right? So we have was it? I think we're looking at the send message to topic. Now we have one for the Mosquito, so send message to topic, and this then in here, considering we were only dynamically dispatching to the full Apache Kafka, will also dynamically dispatch to implementer Mosquito, right? And then we'll get the object. I'm calling it PI for pub sub implementer, and then this will be that object that relates to the Mosquito implementer, and we can call it PI dot send message to topic, which will actually look exactly like this. Do you wanna ask your question, Carolyn, or does this sort of explain?
Well, I don't write Rust.
Yeah.
It sure looks to me like you've already done a switch elsewhere in new where you defined assigned pub implementer. So I don't know if this is a Rust, like I would have expected pub implementer to have functions on it that I could just call without having to type switch here.
Mm-hmm. Yeah, and I feel like that's a fair statement. Even not knowing Rust, I feel like that makes sense. Because we have already done one switch, right? So we we already know the pub implementer, and just the way that that was set up is that here we're doing the switch. Here we're doing a switch or a match in Rust terms for the specific string that's coming from the slide file, which actually populates the enum, and later on we do a match on the specific enum object rather than always doing the string manipulation, right?
Okay, yeah, all right. So new here isn't creating an instance of the implementer. It's just setting an enum. Do I have that right?
Well, it is doing both. So it's getting the enum, the specific enum variant that corresponds to that thing that we got from the slide file, and it's also calling new on the specific implementer that we have.
Okay. So at that point, I expected both implementations that are being returned from new to be have the same interface, essentially, trait, whatever. And I shouldn't have to switch on them ever again. I should just be able to call, send message to topic.
Yeah.
And I shouldn't care anymore what's the backing implementation.
Yeah. And I feel like that's fair.
What David was saying before.
Yeah.
When you had commented and said new is dynamic dispatch, like new is, as he said, it's a factory method. And then after that point, you don't actually need any dynamic dispatch because you're just using, those abstract functions, the interface.
Yeah. And I feel like I'm with you on that one. I agree that I feel like this could be improved because we are doing a match twice and technically already done it.
Okay.
Sort of, I guess, resembles lexing, right? Where we go through a file and we get specific words like, an if, and this is a conditional, and we set it like an enum, and then we go through the tokens, right? Sort of resembles that, but it is, I guess, an unnecessary step in the sense that we could somehow improve it to just call send message to topic because we've already figured it out, right?
Yeah, so the other part I'm trying to figure out is, let's say I'm a cloud vendor, okay?
Yeah.
And I have a couple implementations that are available. What part of this am I writing? Am I writing lib.rs? Am I just doing the cargo toml? Because it seems like librs needs to know what all the possible implementators may be.
Yeah.
Up front, so to do that switch. So like if the vendor introduced their own custom thing that adds a third thing, do they have to edit librs, or can they more dynamically introduce that additional implementator into the system and use it?
So when you say you're a cloud vendor, do you mean sort of like you're a host implementer, or?
Yes, I maybe have some custom implementation that works just in my environment, just on Google or, whatever. Carolyn's amazing cloud host provider, you know?
Yeah. Yeah. I feel like that's actually possibly a shortcoming of Slide or SpiderLightning in the sense that we always go for the lowest common denominator, right? So whatever work that you do in your Carolyn Awesome cloud vendor will have to eventually conform to our pub/sub.wit, which
And that's
I mean can be
that's
improved.
100%
Yeah.
fine.
Yeah.
Yeah. That's not really what I'm talking about. I'm not
Okay.
concerned about conforming to the interface. I'm
Okay.
trying to understand how do I have to fork and edit Slight
Yeah.
here and add my
Yeah.
implementation to that giant switch statement? Is there any way to just go, let me pull in one crate that I made that implements pub and sub and then set it in cargo toml? Or is it every single person who wants to add an implementation needs to be
Yeah.
editing this giant switch statement?
Yeah, no, you're right. So if you want to implement, if you want your pub sub whatever to be
Yeah.
a Slide service, then you do have to come here and edit right now the switch statement as a host implementer.
Yeah. Because like something like this works fine in a single vendor environment.
Mm-hmm.
And people correct me if I'm wrong, but like I feel like getting everyone to agree and play in the same single source when they're providing custom things just for them and their competitors is sometimes really a lot more difficult.
Mm-hmm.
Like if we're running it and Google submits and they're like, well, we want to add our pub stuff, but also it changes 3 things and doesn't implement that, we could go, no, we don't want that. And then that's forcing forks and things. So
Mm-hmm.
like, I was curious if there was a way to think about doing this such that people could provide their own implementations without having to
Yeah.
modify the core Slight code.
Mm-hmm.
Like you could dynamically say, hey, Slight, here are 3 extra crates I want to be able to use in my set of implementations and still be able to bring them in.
Yeah, I don't particularly see a way of doing that now, mostly just because of how different each implementation is with one another. When we're doing the implementation ourselves, we have to sort of figure out little quirks of how to work with things. Like even the Apache Kafka and the Mosquito, they're completely different. And you have to figure out sort of even the way to receive messages is different. So it'll be hard to just specifically tie in a function. But
I guess that's not what I'm trying to suggest.
okay.
So you're talking about the implementation behind, are they called traits? Is that what an interface is in Rust?
Yeah, it is.
Okay. Yeah, I'm not talking about modifying. I'm saying like if I want to be able to provide an implementation that does all the, very specific stuff, but I meet the trait. Is there a way in Rust that I can bring it in and use external traits that bring in external
Okay.
implementations that satisfy the trait without having to modify Slight's core code to be able to use it?
I
Kind of
get
like
it.
a plugin or things like that. I want to be able to bring in third-party resources so that I can
Okay.
compose the set of possible implementations without
Yeah.
getting everyone to agree to edit Slight.
So you're saying you still do an implementation for
Absolutely.
the trait, but then I'm modifying the core. Just in Slide, you'll say, oh, this is implemented in say this repo or this crate or whatever, right?
Yeah. So
Yeah.
like for example, in Porter, you can implement plugins that meet an interface for like accessing secrets in Porter. And you just dump it in a directory and your presence there says I'm going to meet the interface, right? That's just
that's
how we
neat.
do it. And then we can just bring it in and use it. But no one had to like convince upstream Porter to merge their implementation, if that makes sense. Everyone had the ability to just do whatever they want, provide their own implementations without requiring a level of coordination at some common repo.
Yeah, that's definitely not
That
something
may be
I
really
think
helpful for something like Slight.
Yeah, that's definitely not something that I think we had considered. Something we did consider is that Slide is definitely not the one source for implementations of a host for SpiderLightning interfaces, right? Anyone could implement their own host and then make their own implementations for whatever. But I think it would be pretty neat to have sort of like a plugin, right? Then you don't have to modify the match.
Am I misunderstanding what Slight is? Who's using it? If
Yeah.
like if
So
am I using it in order to just run my code on different cloud providers, or
yeah, and
am I
at the end,
misunderstanding?
I'll show you a run. But yeah, Light is just a CLI that has host implementations, so like Mosquito, Confluent, Apache Kafka, that implement the SpiderLightning interfaces. What I'm saying, if you wanted to, you could make your own, say, Slide Carolyn, right?
Sure, but I'd have to re-implement what Slight's doing, right?
Yeah, you would.
Yeah, I'd basically be forking Slight to add my
Yeah.
own stuff because maybe I don't want to talk to you on GitHub.
Exactly. Yeah.
If you had a plugin style way of interacting, people, instead of forking and keeping changes out of your code base, they could use Slight and then provide implementations in some more loosely coupled format that doesn't
Yeah.
require compiling their implementation in.
No, and I'm with you. I think that's a super neat idea.
Okay, sorry.
It's
I
definitely-
apologize for just going on about that.
No. This is great. This is great. It's good that we go into these discussions because I feel like this is what leads to sort of improvement, right? And
Yeah,
going
yeah.
through this is sort of what we wanted to get to. So this is really great. Thank you, Carolyn.
Sure.
Yeah. Anyway, we're pretty much done with the implementation. All we had to do was just, well, I guess spark this discussion in the first place, which is just the dynamically dispatching of to the Mosquito things. Right. So say here we have a sub-implementer, instead of component Kafka, we'll say Mosquito, and we're doing the subscribe. And same thing for the sub pull for message. To Mosquito. And actually, I think this is a place where we have a bit of a difference. Because here we're not returning a key, we're returning a batch of messages. This is just something that was a bit of a difference from the Mosquito implementation and the Confluent Apache Kafka one that we sort of had to get around. Not really the case anymore in the latest implementation, but it's something that we have to do right now. And even for the value, we have to do the exact same thing. We're now returning a tuple, so we don't access the fields. You can just sort of ignore me here. It's really not relevant to the tutorial itself. It's just so that this compiles. And yeah, I think that about covers it. Looks like we have just one error of a mismatch type. Is expecting a reference. Okay, that's also another one that was different. And I'll just fix that real quick. Cool. So again, not really too specific to the tutorial, is just going through the topic and mapping to effective strings. Cool. So with that, everything that we had to do in the lib file is done. And now we can move on to the last step, which is what I showed you right at the beginning in the slight run command. And now this is possibly where we could also make use of that sort of plugin style, Carolyn, because in here, other than modifying the lib and slide, you're also modifying the actual run command.
Okay.
Yeah. So in here, you'll have to add a new pub sub implementer, right? So you'll say pub sub.mosquito. And yeah, what this does is just it clarifies that in the little match statement that we have. Oops, I think I actually forgot to change the size of the array. Yeah, that now has 2 items. And so what that does is just down here, and this is a match, right? So a switch. It now will check that it contains the specific resource type. So say that it found a slide file and it parsed it and it found pub/sub.mosquito. It now conforms to that, and it will still link the capability. Otherwise, it never would, and it would just show an error saying that this was an invalid config. Cool. Now let's just finish up with going to the examples and creating a slide file to run to run the example with our new Mosquito implementation. So in the PubSub consumer demo, we'll create a new file. Let's call it, with the other one we already called slide file. So let's call this Mosquito slide file.toml. And in here, we specify a spec version. Our spec version right now is 0.1. We specify a global secret store. So this is where all our secrets are at. And this is just, we're using configs AZ app. So this is Azure app configurations. And right now what it holds is just, say, our host, right? So we have configuration that says localhost or a port that says 1884. And here we have capability. And the name is what we defined. So pubsub.mosquito, or if we had assigned Bob, it would be Bob. And if you had more capabilities they were using, you would just add, say, another capability. That would be name, pubsub. Then you could have like Carolyn, awesome vendor, right?
My cloud's the best cloud.
Yeah. And yeah, so that's the slide file. Actually copy this and paste it over on the producer side because it uses the exact same thing. And yeah, now the exciting part, we just run it. To run it, let's just add, so we have a make file, right, that just has all the run commands for all the examples and the builds and so on. So right here, I'm just going to create a new rule real quick, just so that we don't run all the examples. We'll just run that one specific one. We'll say, we can call this a run feature, right? The new feature that we're implementing. And just have it on the side. So I'll paste it here. And we'll go through what this means. So in here, we're just setting the log level, something that we find at the top is just trace. So we get all the trace log level stuff. And we're calling the slide actual CLI, the binary, which we just defined that here is in target release light. And we pass in config. So this is what we had defined in the slide main.rs, right? We pass in accepts a config, which will be pubsub producer demo. Oh, actually, I was looking at the wrong one. Sorry, right here. Yeah, pubsub consumer demo, and then Mosquito slide file toml, and then we run. So we are calling the run command, which receives a module, the Waza module. So this will be the pubsub consumer demo Waza module, which we haven't built, but we'll build in a second. And the Rust log, again, same thing. We're just doing sort of a parallel process to also call the producer together with the consumer. All right, let's save this. And now the part I fear the most, building. Mostly because I feel like this might take a bit. Hopefully not. I did build it right before. So
Just start submitting time cards for whenever you have to compile stuff in Rust, so you can justify a bigger computer.
Yeah, right.
Like today, I spent 4 hours compiling.
Oh no, was that in Go or?
No, I was just using that as an example and be like,
Yeah.
David, if you want 4 more hours of productivity, I need a MacBook trash can or whatever the coolest one is now.
Although I can't complain because David did send me an M1 recently, so.
Nice. How much did that speed it up?
I choose not to create evidence against myself. No, I haven't tried it yet, but it's there, and I'll get to it soon.
Oh man, I switched from an Intel to an M1, and it went from like 10 minutes to under 1 minute. It was ridiculous, the performance improvements. Yeah, it's for compiling Go.
Wow, you're making a good argument for me to just do that now and not be productive for 4 hours.
You should definitely spend your afternoon benchmarking that.
Right.
It is a big performance increase.
Yeah. I mean, we did finish in 44 seconds, so at least there's that. And then we have to just build Rust, which is just an example, but this should be done in like a second. Yeah, there you go. Cool. So with this, we can just call, what was it called? Make run feature. Oh, and just on the side, I am running Mosquito, so you can see just the actual broker, right? So we're listening to port 184, and yeah, actually maybe I can put this on the side, just so that we view it when we run it, if it all works. Feature. There we go. So we sent a message, and we got, you remember we called that batch, and we get key 0 value 0, key 1 value 1, key 2 value 2. And in the broker, we saw all the client connections and yeah, new client connection, new connection. I think it only logs the connections. We see our auto ID as well. And yeah, there you go. And maybe I don't think I showed the actual example applications in detail, but I guess retrospectively, what we were doing is the producer was sending a message with key respective to the index on the for loop that it was at. So it would just send 3 messages with a value to a topic called Rust, and the consumer would consume the messages to the subscribe topic Rust, and then just log the received messages with the key and the value. And that is exactly what we saw. Let me make it bigger right here. So right, we saw the key was batch, and the value key 0 value 0, the batch key 1 value 1, batch key 2 value 2. Shut up. So with this, hopefully you sort of have what you need to start implementing capabilities. I mean, obviously I'm biased, right? But I feel like it's not too bad. I feel like Joe and I, we created a bunch of like things to make it sort of easier with dynamic dispatching and so on. At the beginning of Light and SpiderLightning, you have to create a new crate for every single implementer that you had. Nothing will be dynamically dispatched, so you have to go from the very beginning, like using with bindgen and so on, right? And now, so you just touch that one crate, which in a plugin sense, like Caroline mentioned, is worse, but makes it easier to just, I guess, create a bunch of implementations really fast. And yeah, actually, we do have, I think, or we'll have a couple of issues to create some new implementations or implementers that were requested to us. Right, Joe? What was that? The Redis pub sub?
Yeah, we got a few.
Yeah. Thanks. So
Redis
you want to
streams.
Yeah.
RabbitMQ, Cosmos DB, and event hubs.
There you go. So if you want to try your hand at creating any of those implementations, this shouldn't have probably given you what you need. All right.
So if you did want to do distributed as crates, you could make one crate just for like Azure, one crate for G-Cloud, one crate for all the Apaches. You know what I mean? You could make like a thing of like a good set of implementers that go together.
So your concern is mostly just conflicting implementers or different vendors touching the same file?
I mean, it's not about touching the same file at all. It's really not. I'm talking about like the people problem or friction, where it's like, one, you don't want to be supporting Azure's pub sub stuff, right? Or whatever it is, Azure's implementation for whatever service. Like, you want to be able to push that to the people who are closest to it and allow them to maintain it. And you don't want to have everyone agree on how to do things in a single repo, especially when they're competitors with different interests. So
that's fair.
And as a user, if I can go, this implementation sucks and needs a fix, I can make one small change just to create somewhere that fixes their implementation and load it in and not have to know how to edit all of Slight and how you wire everything up, to be able to just register a different implementation, like my fixed fork of Google because they were on vacation for a month or something. Like it deals with a people problem. Like technically there's no real problem with shoving everything in here, except the experience shows that it's hard to get certain people to work together and agree on like, this is how we're all going to do integration tests. Well, now we need an integration test that work against Google and Azure and, whatever cloud, AWS, all in this repo and all having the secrets for all of those environments in the build environment for this repo. Like, do you see how it just kind of builds up a lot of
I think that's a
other
solid
problems
concern,
you don't want to solve?
Yeah.
Yeah.
People are complicated.
Totes.
So, yeah, thank you, Carolyn, for bringing that up. I think like that's a valid concern, and I think we could even possibly create an issue, I think, for that, and tackle it. Maybe not in this sprint, but maybe the next one, and I guess go from there. And I mean, if you're watching this video, or Carolyn yourself, if you want to also, pick that up, possibly will be harder, but could be fun if you want to start working with SpiderLightning.
Yeah, because I think, like, I'm not trying to say anything about what you've got here. I was just suggesting like a next evolution of it that would really increase the likelihood that other vendors would contribute.
Yeah, and that's what we want. So I feel like at the end of the day, that could possibly be the way forward.
Yeah.
But yeah, that is all I had. Finally got this meeting done. I feel like I was promising it for like 3 weeks now.
This is really great feedback too. Thank you. Dan,
Yeah.
great presentation.
Thank you,
I
Carolyn.
think you stated your case very well. And Carolyn, excellent feedback. Thank you.
Yeah. Hi, Simon, as well.
Yes, Simon. You as well.
All right. So if there are no more questions, I think I can give everybody 5 minutes back.
Thanks so
See you
much.
all,
This was
stand up.
great.
Yeah. Thank you, everyone.
Bye.
Bye-bye.
Bye.